Okay, design patterns for enterprise development. Now, this course has changed name a few times over the years. I gave it this name a couple years ago. It used to be called Enterprise Database Programming, but I want to be upfront with you. Don't be fooled by the title. We are not, like design patterns, that's a whole university diploma, right? We aren't going to learn everything there is to know about every one of the established design patterns, right? What we're going to do is we're focusing on full stack development. But as we do so, I changed the name because I want to try to highlight so you can see, oh, those different patterns that are out there, that's where we're applying this one. And that's why this code works well, right? And things like that. So we aren't going to have a test on everything about design patterns. I'm just trying to give you the value added here of understanding how established patterns benefit us as we're doing our development, right? Okay. Come on, clickety click. If you build it. No, it's how you build it, right? Okay. Common sense tells us, right? You go to build anything. Somebody else has probably built something similar before. Trial and error is a great thing to learn from, but if you can learn from other people's trial and error, that's even better, right? And that's really what it comes down to at a certain point. Software developers, like anyone else, have learned through experience what works and what doesn't. Okay, and they've come up with some guidelines on how to go about software development, things that are tried and proven, okay? Through testing, verification, and so on, okay? There's confidence that certain approaches, certain principles and patterns improve things like the ability to reuse code. So you're not reinventing everything from scratch every time you build an application. Okay, the efficiency of the code, that it runs very well and very fast and so on. Testability. I cannot emphasize enough how important that is. When you get hired, half your time, I almost can guarantee, is going to be doing testing to make sure code is doing what it's supposed to do, that it's not going to crash, and so on and so forth, right? Reliability, maintainability, all these things come from following good established patterns. That doesn't mean we don't have to think on our own, but it's good to know these patterns to begin with. And as I say here, they've been around a long, long time, right? You know, going back, boat builders and engineers and so on and so forth, tradespeople of all sorts, they have patterns that they follow in their work as well, right? Interesting, if you do some research, you'll find that the very first published catalogs of standard design patterns and so on come from architects, okay? How to build a house so it doesn't fall down, so the roof doesn't collapse, and so on and so forth, right? So that's, you know, going back in history, thousands of years, actually, you could find catalogs like that. So it only makes sense that software engineers would do the same thing, right? Okay. So where can we go to find out documentation on these? Well, one of the most famous books, okay, is this one here, Design Patterns, Elements of Reusable Object-Oriented Software, okay? Put out by, they're often referred to as the Gang of Four. If you just Google Gang of Four, you'll find out all kinds of information about them there, right? So this was often considered, as I say here, the Bible of object-oriented programming design software design patterns, right? And if you have the download the PowerPoint, you can click on that link and find out some information about the book as well, okay? Mind you, we are talking 1994. Does a George Orwell pop into mind for anybody? Okay, not quite the right year, but anyway, that's all right. Martin Fowler came on with another book that's highly, highly respected in the industry a number of years later, and it takes things to the next level, so to speak, from the work of the Gang of Four. Scenarios that didn't exist back in 1994, distributed systems and so on, which weren't around then, right? Great book, by all means, you know, grab a copy if you want. The only thing I'll warn you is it's a very advanced book. It's not the easiest to read, although, you know, Martin might be mad at me for saying that. Sorry, Martin. But, you know, it's a very advanced book itself. So I might encourage you to have a look at these. Actually, I have one of them here. Head First Design Patterns, right? Much more accessible in terms of how it's written, a bit of humor and tongue-in-cheek stuff in how the authors have put it together as well. Maybe a little bit more accessible in terms of easy to understand. There are a number of versions out in the Head First line, so just Google them as well and feel free to have a look at those, right? But for this course, you don't really have to look at any of these. These are options if you're really interested in design patterns and want to take it further. I wanted to give you this reference so you know how to go about doing that if you like. Our goal in this course, right, isn't so much the theory of software engineering, right? We're focused on building the college level in general compared to the university level, right? A lot of theory in university, okay? But at the college level, we're focused on rolling up our sleeves and building things. So that's what we're going to be doing here. We're going to be looking at building fully functional, full stack applications, right? You probably heard that term many times, okay? Go on YouTube, you'll find all kinds of full stack references and so on, right? So as we do so, as we focus on this type of development, I'm going to just try to point out and how we can implement a lot of good design patterns relative to the success of our application as we go, right? The pattern we're going to be focusing on mostly is the Model View Controller, or MVC design pattern, right? Actually, the other day I just came across a YouTube video by one of the software people out there that does a lot of videos, and he commented that, you know, if you're just going to start off learning one particular approach to software design, he highly recommended MVC. And I won't go into all the reasons. Maybe I'll find, I wish I should have saved the link to his video. I could have put it up, but I'll probably try to find it again. But you'll actually find that many people, when they refer to this course, the common name is just the MVC course, right? Because that's really the focus of the course, is this one particular design pattern, okay? What is it, MVC? Well, it's a framework, or basically a programming design pattern. It's been around for a long time, okay? It's used in many languages, not just C#. In fact, originally it was introduced with Smalltalk back in, 1987, going back a few years now, right? But you know, if you create a brand new Ruby on Rails application, it is already MVC. Like, that is just the standard template for any application done using that tool and so on. Mind you, we won't be using that. We're going to be using ASP.NET Core and C#. So that allows us to build on what you've learned already about that approach to object-oriented programming. C# is a great language. There's nothing wrong with it in any way, shape, or form. It's as good as any other object-oriented language out there, better in many ways, right? So, as I say here in plain speak, it's a way of organizing code, but not just our code, but the flow of control within the application, right? So that we make our work easier to develop and also easy to maintain. All right. But in addition to MVC, what else we're going to be using? The unit of work pattern, dependency injection. Now, unit of work is pretty straightforward. We'll talk more about it, but basically it means you start something, you get it done, and you wipe your hands when you're finished, right? Mom asks you to clean up the kitchen. Well, it's done, you put everything away, you hang up the towel when you're finished, and boom, your unit of work is complete. It's not that different, right? Although it's in software. Dependency injection, we talked about that last term, right? In your client-server, right? When we created a client and so on, we looked at dependency injection a little bit. Repository as well. We created repositories and used that as a design pattern, okay? We'll be expanding our use of these. They both give us separation of concerns. That's really what dependency injection is all about, okay? Client and server session state as well. And a lot of the things that you've done with your database work fit in here as well. Things like having a primary key or unique identifier for any, whether it's a database record or an object in your code, right? Foreign keys and the mapping of a foreign key to a primary key and so on, okay? Optimistic concurrency, well, you did that, right? Remember, you added concurrency control with your SQL work and so on and so forth. What we're going to discover is that our tools we're using and the project type we're using, MVC with ASP.NET Core, using Entity Framework in particular, implement most of these for us virtually automatically, right? So, less work for us to do ourselves, but it's good to know that we're following good patterns. Now that unit of work, as I said, it's like cleaning the kitchen, okay? Fancy description here: maintain awareness of objects affected by business transactions, coordinates the writing out of changes and the resolution of concurrency problems. In other words, we always leave it in a steady state. We make changes, everything gets saved, boom, we're ready for the next round of changes, right? That's how to put it in layman's terms, right? So when you're pulling data in and out of a database, keep track of everything, make sure everything is put back where it needs to be. Clean your room, right? Just like Mom used to say to you. Okay. Guess what? It's fully implemented for us, right? Entity Framework takes care of this. That's it. Check that one. It's done. We're good, right? Repository. As I said, we talked about this last time. This is so important, right? The whole idea is you have, well, think of it as the front end of the program. The repository hides the complexity of the whole data access layer. Are you working with Oracle? You're working with SQL Server. You're working with MongoDB or another non-relational database. Okay, or maybe you're just working with data stored in XAML files or whatever, right? Doesn't matter. The idea is that we define an interface for our repository. We give it capabilities like add a record, update a record, delete a record, whatever. Give me records, filtered by this, that, or the other thing. We defined as an interface how it gets implemented in the actual repository. From the front end of the program, we don't care, right? Who cares, right? As long as it does its job. And the beauty of that is you can swap out the entire back end, right? What kind of database system you're working with, okay? You can just replace it with an entirely different repository that implements the same interface. And nothing in the front end of the program has to change whatsoever. Beautiful design, right? Makes it so easy to maintain and make changes as things go forward, right? So as I say here, hides the complexity of the data persistence layer, okay? We just know we say .add or .edit or whatever, right? Pass the right information. And then we can swap out the data persistence layer itself. Guess what? This as well is already implemented by Entity Framework using the DB context object. Boom. Okay, even last term we did a lot of work creating our own repositories. Well, we don't even really have to worry about it. Okay, dependency injection. Do you know what I'm talking about here? The idea is, you make a class and it depends on some other object. Well, you could just, create the object itself inside as a property in the class and away you go, right? Trouble is then that object depends on the other one. You can't run it up and use it without the object it's depending on, right? Whereas with dependency injection, we say, hey, you need to have an object of type A and object B. Well, what we'll do is we'll inject it at the time, usually in the constructor, right? As we create object B, we'll inject object A. Why that's important? Well, it plays a role in many aspects, but in particular for testing. It gives us separation of concerns as well. It gives us the ability, for example, say we want to test object B, object A is connected to the database system. Well, we don't want to just to do some unit testing on object B. We don't want to spin up the whole database system. No. So we can create a little fake or mock object that just gives pat answers to all the things that, that it might have to do for object B, right? And we inject that in when we construct object B. Now we can do all of our unit testing to make sure all the other internal functionality of object B is successfully doing what it's supposed to do without ever having to worry about creating the database, connecting to it, slowing it down by our testing or anything else, right? Okay. Gives us loose coupling in our code, so it's much easier to test and also easier to maintain. All right. That salmon hammer, I'll have to look for it again. I've got to find, I wrote it myself. There's a little story I wrote, kind of tongue-in-cheek, like a children's story about two objects and how they use dependency injection to live happily ever after. I'll try to find it. I can't think of where it is at the moment. But anyway, I shouldn't have mentioned it, but it's okay. I'll try to find it. All right. Guess what? ASP.NET Core MVC has built-in support for dependency injection. It already has a services container, and we'll see how we can just go ahead and use it, right? So all these good things are coming along almost for free. It supports both constructor injection, that's the one I mentioned, passing it in the constructor. There's also action injection. We can have the options pattern and so on and so forth. It's all supported inside of MVC. So let's get down a little bit more into the details of what MVC actually does for us, right? Gives us that separation of concerns, gives us enhanced dependency injection and so on. But basically it's a way to separate our code into different areas of responsibility, right? The controller basically handles all the input, The model has the logic as well as all the entities. So, think of it as sort of the database plus, right? And then the view is the presentation. I think it's almost more helpful to talk about it in terms of the flow through the code. So how does MVC actually work? Well, remember for a minute, what we're talking about here is a web application, right? The web is different from when you create, like we did last term, whether it's a UWP or a Maui application or whatever else you're working on, it's running on the PC full time. Web applications are different, okay? They wake up, respond to a request, send a response back, and if nobody else asks for anything, they'll go to sleep often after 20 minutes, right? And just wait for the next time somebody has a request for the web application. So just bear in mind that that's the kind of environment we're working with here. So how does this work? A request comes in. It gets routed to a controller. Remember, the controller is kind of the brains of the system, okay? It handles all the HTTP requests, and it looks at it and says, okay, what are we going to need to satisfy this request? Okay, maybe it needs information from the database or whatever else, right? So it pulls together whatever's required, bundles it up, okay, and then basically passes it off to the view. The view is that visual representation, okay? Think of it kind of like you've done work with mail merge in Microsoft Word, right? You have like a template, maybe for a letter, dear blank, okay? Thank you for being a customer since blank. Right? And then you have data. Maybe it's just an Excel spreadsheet or coming from a database, and you merge it in. So you produce a letter for each John Doe and Jane Smith and so on and so forth. Thank you for being a customer since. And it just inserts all the right information into that document in the right place. Well, the view is kind of like that. It takes all the data that's being given to it, merges it in, and puts it together. So in the end, it all gets combined together into the response, which then goes back to the client. So maybe that kind of helps explain the flow a little bit through MVC itself. Okay. So in terms of responsibilities, the model, these are the fancy terms for it. Representation of domain data, right? Business logic to persistent mechanisms. That's all part of the model, right? The view, well, that's the UI, right? The interface, it's a representation of the model. Okay. So if your application is focusing on department and employee, and you're bringing up an employee records on the screen, right? An index might show you a list of all the employees, right? Go into details on one, and you can see all the details about them and so on, okay? The C, or controller. Sometimes I'm tempted to say, instead of controller, I almost like the phrase conductor. There he is up in front of the orchestra, a little more of this, a little bit less of that, bring up this, conducting everything. That's kind of what the controller is like. It's the intermediary between the model and the view. It's like the brain handling the requests, binding the data, returning the views, looking after the overall flow of information through the whole system, right? Okay. All right. So, learning items we need to be successful in this course and in this style of development. Well, fortunately, we have a lot of stuff we already know. We're familiar with C#. You've done 2 courses now with C#, so you should have a pretty good handle on how these objects and classes and so on work, right? Actually, you're going to find in many ways our approach to building our classes, our models, is much simpler than some of the work you've done before. We use what we call POCOs, plain old CLR objects. Virtually never do we put anything in a getter or a setter. It's just simple objects. It just stores the data, basically. Everything else is handled elsewhere in the system. Of course, HTML and CSS, because after all, it is a web app, right? So we do need to work with those tools. But a jQuery, you've done some work with that as well. And of course, SQL. It's good to have an understanding of how databases are put together and how they work, relationships, foreign keys, all that stuff, right? Good. Some new stuff we have to know. Razor. Okay. I did shave before I came today. No, that's not what I'm talking about. Okay. Women shave too, I know. Okay. All right. Razor is actually using C# inside of a web page, almost like it's a scripting language. Okay. So instead of JavaScript, you can use C# as a scripting language inside the page itself. Okay. Now, mind you, it only gets interpreted on the server. Okay. Unless you're going to use something like Blazor, which uses C# as scripting on the client side. But anyway, that's what Razor is. Entity framework. Think back to last term. Remember, we talked in client server. You did a lot of work with databases. You made your stored procedures and triggers and functions and all that good stuff in SQL, right? And then when it came to building a front-end application for it, we often talked about an object relational mapping system. Because in the UI program, right, we work with objects. It's object-oriented design. Objects don't quite fit the same paradigm as database tables with rows and columns, right? So we often found that an object relational mapping tool made our life easier, and you used Dapper mostly last term. But we mentioned at the time that another much more powerful object relational mapping system is Entity Framework, right? So we're going to use that, and one of the things it's going to allow us to do, believe me, it's kind of going to blow your mind when you first see it. Code first, right? You've always started with the database so far. Define your model, build your tables, okay, all your columns, all the different restrictions, check constraints, and all the different things, foreign key constraints, and you built the database, and then you think about building an application on top of it. Well, we're going to flip that entirely on its head, right? We're going to start with our objects. We'll define our model classes. And then any framework can say, oh, okay, you want these classes that all relate to each other and so on, persisted in a database. Tell me what database you want to use, and boom, any framework is actually going to go and create the whole database, create all the tables, create all the constraints, and everything else for us. We make a change to the model, boom, you do a new migration, and it goes over to the database and modifies it to match the new configuration of your model. It's amazing, okay? So that's what we're going to focus on. You've done the other, so we're going to, by the way, Entity Framework can do database first as well. Okay, and we'll look at that later on in the course, but for now we'll focus on code first because you've never had a chance to do it before. Another new item is LINQ, Language Integrated Query. That's what it stands for. We'll talk more about that. That'll be our next main discussion. But basically the idea is, guess what? All you learned about SQL? It's good to know, but we're hardly going to touch it. We're going to do most of our queries using C# and Language Integrated Query, right? So when we want to select certain things, you know, when, where, ordered by, and so on and so forth, we'll do that all in C# now. And the tool will write the actual SQL for us. Wouldn't that have been nice in the test last term, right? Have a tool that wrote the SQL for you? Well, that's exactly what's going to be happening here today, right? LINQ. And finally, Bootstrap is another new item, just worth mentioning. How many people are familiar with Bootstrap? Yeah, there's usually a few in every class I find. It's a free, open source CSS JavaScript framework. Okay, it was first developed by Twitter, and then they made it open source for everyone to use. Right? If you really don't like Bootstrap, you can just sub it out and put in a different one that you like better. Right? But I'm going to ask you to stick with Bootstrap for this term anyway. Right? Because there's no harm in using it. It makes our life easier. It's already there. I'll show you some nice tricks on how to make good use of it as well. Okay, so that's our bucket list of learning items. In terms of resources you're going to have, well, whole pile of textbooks you have to run out and buy. You know, we now have not even a single textbook in our entire diploma program that is required purchase anymore. When I first started here, we had a stack of books. You had to go out and buy them all at the bookstore and so on, right? It's hard for book publishers to keep up with the rapid advancement of software development, right? I used to have a few free ones that I would distribute, nudge, nudge, wink, wink. Here's a PDF file. But you know, even them, they've gotten so out of date that I don't really do that anymore. Plus, I was told not to. Okay. Now, there's all the recordings that I'm going to do in class, right? So, as I said, I'm throwing them up on YouTube. I apologize. I changed all the settings for my account in YouTube so that there would be no ads. But YouTube is evil, okay? Google is evil, right? So I've heard from students that...
There's one ad for 1 minute.
Yeah? You know, there's not supposed to be any ads. But you know, if there are, I apologize. Of course, you can always get out a student YouTube account, pay your $5 a month or whatever it is, and then you can watch all your YouTube without any ads. That's up to you, right? But I don't know. I'm going to keep on doing it. I only have one more term to go, and I don't want to switch to use a different tool, so I'm going to still put them up there. Hope that's okay. All right, there's also, of course, we don't have textbooks, but there are a number of online tutorials, right? And that's going to be some of the first homework I'm going to be assigning to you as well. Some free online tutorials for you to do. Okay, and I'll put lots of resources up in Brightspace as well that'll be useful to you, right? Almost done. Tone of the course, okay? This is adult education, okay? You're even in year 2 now, right? So there's going to be no hand holding. If you don't want to come, you don't want to do anything, I'm not going to lose any sleep over it, right? If you don't want to show up for tests, that's entirely up to you. You're here to get whatever you can, and I'm anxious to kind of give you as much as I can, right? But you know, you are adults, so it's entirely up to you. We're gonna you're gonna be learning a lot, I said, by demo, by playing, by discovering as you work. And it's important to note this: we're going to be doing 2 projects in parallel. So I have a teaching example project. I'm going to use a medical office because I love playing doctor. Okay, no one chuckled? All right. Okay, no, I didn't mean that in a crude way, honestly. No, it's just it's a familiar scenario. We have doctor, has many patients. A patient has one primary care physician, right? A patient will have many appointments over time, reasons for their appointments, and so it gives us lots of a familiar example, easy to understand. So we're going to build this full stack, fully functional application based on that scenario. That'll be the one I demonstrate in class, right? In parallel, you'll have your homework project, which this year is going to be a music collection, right? We have artists and albums and songs and all the instruments they play. And, you know, I had a discussion with somebody in the summer who was really into music, and we were talking about music collections and so on. So, is he in the room today? I don't see him. But anyway, it's his fault. That's why I decided to do a music collection as our project. So I think you'll have fun with it. I think it'll be a good example. Now, as I mentioned, you're going to build it up over time, right? And maybe just to talk, I think I touched on it before, but there'll be due dates, right? So like there'll be project part 1, then part 2. You saw it in that schedule that I had up, right? Now, the truth is, I break it down even more. Each part might have an A, B, and C. The reason I do that is, this is a lot of work, folks, right? To do, say, project part 2, you're probably looking at 24 to 30 hours of solid work to get it done. If you leave that to the last minute, the day before the due date, there's no friggin' way on earth that you're going to be able to get it all done successfully. So that's why I'll put up like part A and I'll say, try to have this done by the end of this week. And then part B is for next week, and then part C and so on, right? Just to encourage you to keep up, because if you fall behind, there's too much work to get caught up in a real hurry, right? So the other aspect to be aware of, though, is there will be a due date to hand it in. Now, as I always do, there'll be an opportunity to hand it in late, okay? Usually I give a 10% a day penalty. That's our department standard. Mind you, I always treat a weekend. I often use Fridays for due dates. And then the whole weekend just counts as one day, right? To give you a bit of a break there. But at some point, whether it's Tuesday or Wednesday or whatever, I actually have to have a hard, nobody can hand it in after this point in time. The main reason for that is, because these are big, complex applications, we always publish the solution to part 1, part 2, part 3, and so on, right? And that is there so that if a student struggled, they just couldn't get their application to work, well, they can still hand it in, get all the part marks that they deserve, get a decent mark even, right, on that part, but they aren't held up from going forward, right? They can take the posted solution, say for part 1, and use it as the starting point for part 2, and then carry on and go forward, okay? So that's why it's laid out the way that it is. So it does come to a point where, no, you can't hand it in anymore because the solution is up there, right? Nothing I can do about that. But I think it's the best compromise on how to run the course. So that's it. Yep, we have a little bit of homework to get started, so required. Please, I'll show you again in Brightspace in a moment where the first online tutorial, Get Started with ASP.NET Core MVC, is kind of our textbook tutorial. You'll even see in the link to the tutorial, I have it called that, textbook tutorial, right? There's also a read-through background document to read about MVC Core, an overview of how it works. I encourage you to take time to read through that as well. And there's a link there up on the Razor syntax. That's where we use C# as a scripting language, right? Don't spend too long on that one, to be honest with you, but skim through the first part of it anyway. It'll give you an idea of what and how we're going to use it. We don't have to memorize that whole thing. When an issue comes up, we'll deal with it then. But it's good to have a look at that as well. Any questions? All right. Well, I'll stop my recording.